Chapter 5, the periodic table. The periodic table is kind of the nuts and bolts of our chemistry course. We can get a lot of information, and we use a lot of information off of the periodic table. The periodic table was initially organized by Dmitry Mendeleev in about 1869. Dmitry Mendeleev is a Russian comrade, and he organized the elements by increasing atomic mass. Well, which kind of makes sense. Remember, the mass number is the one that's a little bit, it's the longer number, it's not the atomic number. The mass number is the protons and the neutrons added together, and the average atomic mass, you should remember from chapter 3, takes into account all the percent abundances of the isotopes. He also kind of had elements with similar properties grouped together, so he kind of repeated. If he noticed that two elements were kind of the same, say they had very similar characteristics such as density or possibly metallic character, then he would group those the same. And he did have a few discrepancies. Some that you may notice on the periodic table today could be cobalt and nickel. Had we stayed with, or had we used Mendeleev's periodic table, we would have actually swapped those on the modern day periodic table, because nickel is slightly has a slightly lighter mass than cobalt does. Mendeleev actually predicted properties of undiscovered elements, and right here we've got an example of something that he predicted. He called it escasilicons, probably because, or not probably, because it is directly underneath silicon. It was later named germanium in 1886, so not very long after he predicted the properties. He said that this escasilicon would have a very high melting point. This is what he predicted. This is what he thought was going to happen. This is what he actually observed. Very high melting point, 900 degrees Celsius, is quite high. He said the density of this metal is going to be approximately 5.5 grams per milliliter, which the observed property is 5.47 grams per milliliter. And of course, if we were using a different or a less precise instrument, we may very well get the same thing that Mendeleev got. As far as significant figures is concerned, the color of the metal he predicted to be a dark gray or grayish white. He said the oxide formula is going to be the EK, as he, or the ES as he named it, O2, meaning that it has it can pick up 2 valence, or it can pick up 4 valence electrons. Talk a little bit about in a later chapter. And he gave several other properties, even the density of that oxide. So he was very successful in how he organized this table. I mean, it was very close. Even if you look at the modern day periodic table, we are very close to organizing it according to increasing atomic mass. Now, in 1913, a British chap by the name of Henry Mosley came along and said, hey, wait a second. Why don't we organize these elements by their increasing atomic number or increasing number of protons? When Mosley organized his periodic table in this fashion, it did resolve some of those discrepancies that Mendeleev had by organizing when he organized it by atomic mass. Now, so let's look at the periodic table and how it is organized. Let's start off with metallic character. I have several colors on here, and in class you're actually going to be coloring some maps of the periodic table. The green, or I'm sorry, the yellow is going to be what we consider metal, or are going to be what we consider metals. The green color is going to be nonmetals, so this includes all of our gases over here, and hydrogen. Remember, hydrogen's over there. Hydrogen's a little bit odd in how it's arranged, as far as it's very reactive, yet it's also a gas. It can be positive or negative. Hydrogen's just a weird little animal. We're going to talk more about hydrogen and its properties in a later chapter. And the stair step, or along the stair step, we have the metalloids. You should remember the metalloids from chapter 1. They have properties that can assimilate to both metals and nonmetals. Now let's talk about the different blocks that we have. Okay, the pink color is are our main group elements. 10 typically the pink are going to be our valence electrons. In terms of electron configuration and orbital shells, the first two groups are our S sublevel, and the other group is going to be our P sublevel. And we're going to talk more about that, or we have talked about that, and we're going to talk more about it a little bit later. The yellow color are our transition metals. Now, they are not in valence. Those are typically not used in bonding, though we could open up potentially d orbitals. That's a completely different class discussion, much higher chemistry. And the green color are what we consider the inner transition metals. The inner transition metals, or that would be our F block. The yellow would be our D block. The green would be our F block. S, D, P, F block, and you'll label that in a little bit later.